Welcome to homework.
Okay, so here an alpha particle has a velocity v given as 550 meters per second, right? And it passes through a uniform magnetic field of magnitude b vector is equal to 0.045 Tesla. Now alpha particle has a mass of 6.6 into 10 to the power minus 27 kg and has a charge q of positive 3.2 into 10 to the power minus 19 coulomb. The angle between V and V is also given, that is 52 degrees. So the question asks us in part A, what is the magnitude of force acting on the particle due to the field? So force acting on the particle is equal to Q times the cross product of V and V, right? So if you want to write the magnitude here, so F is equal to QVB sine theta. Now you know Q, you know V, you know B, you know sine theta. Just plug all these values here. This gives F is equal to 6.24 into 10 to the power minus 18 Newton, right? Okay. And this ends the part A of the question. Now part B says to asks us to calculate the acceleration, which is given by force upon mass. So mass is given, force we calculated in A. Okay, let me write this into 10 to the power minus 18 upon what is the mass? 6.6 into 10 to the power minus 27. So this gives me the acceleration is equal to 9.45 into 10 to the power 8 meter per second squared, right? So we're done with part B of the question. Let's move on to part C. Does the speed of the particle increase, decrease, or remain the same? Okay, we can answer this in two different ways. Here, as you can see, force is the cross product of V and V, right? So if you see the velocity and displacement are in the same direction, this implies force dot displacement equals to 0, right? Because F and V are in same F and V are perpendicular, because V cross B gives the product, cross product of V and V is perpendicular to V, right? So F is perpendicular to V and F is perpendicular to D as well, because displacement and velocity are in the same direction. So F dot D equals 0. This implies no work done. So when there is no work done, this implies no change in velocity. Okay. The other way that you can see is force is this. So ma is equal to q times v cross b. And if you see this again using the relation, the relation between the cross product and the vectors doing that product, if acceleration is perpendicular to velocity, hence this implies no change in velocity. Okay, so whichever way you like to say, and hence this ends the solution to this question. Thank you for watching.